Hello, my dear friends. I welcome to my YouTube channel. In this video, I want to introduce continuity and differentiability. Already under continuity, I finished three video lectures. If you not watch that previous videos, please watch that previous videos and come to this video. Under continuity, now I want to continue this video especially for class 12, CET, NCERT, NET, next APSET, TSSET, KSET and Maharashtra State set also very important. So under continuity part 4 complete guide today we want to discuss. So my dear friends, if you not subscribe my YouTube channel, please subscribe my YouTube channel as Theorem Manohar and like this my YouTube channel and share to your friends and write your comment on my comment box. Now continue on this video lecture under continuity part 4 complete guide. In this continuity part 4 complete guide, we will discuss about CET, mainly CET and further NET set exams we will discuss. Further NET set exams we will discuss. Questions we will discuss. So first question, see here, first problem is under CET basic level question, CET question I choose. Find the value of k so that the function f of x is equal to x to the power of 5 minus 2 to the power of 5 by x minus 2 if x is not equals to 2 and f of x is equal to k if x is equal to 2 is continuous at x is equal to 2. What do you want to find k value? When if f of x is continuous at x is equal to 2, we want to find k value in this case. So for this purpose, just find k is equal to f of a value. F of a value, how you find as limit x tends to a f of a. We know that since f of x is continuous, so that's why we know that f of a is equal to limit as x tends to a f of a. So that's why by checking this condition, we will find this k value. So k is equal to f of 2 here. Why? Because x is equal to 2 means k is equal to 2. Limit as x tends to 2 f of x. F of x is equal to what? X to the power of 5 minus 2 to the power of 5 by x minus 2. Directly by approach x as of x tends to 2 means this becomes 0 by 0 form. So that's why by avoiding this 0 by 0 form, we must follow the L'Hospital rule. So that's why that k is equal to limit as x tends to 2 by differentiating d by dx of x power 5 means x power 5 means 5 to the power of x to the power of 5 minus 1 is equal to 4. This is the differentiation of x power n formula, n into x power n minus formula. So by x as x tends to 2 means x approaches to 2. So that's by 5 into 2 to the power of 4. 2 to the power of 4 means 16. 16 5s are 80. So that's why k is equal to 80. By this way, we are finding k value. So that's why this type of problems very important for all competitive level examination. So if it is clear, I will move on to the next problem. This is also very important for IIT, CET level, JAM, KSET, also KSET to APSET also very important. Find the value of k so that the function f of x is equal to x cubed plus x square minus 16x plus 20 by x minus 2 whole square if x is not equals to 2. Next, f of x is equal to k if x is equal to 2 is continuous at x is equal to 2. So this is a function given. Before going to that, first of all we have to find factors of this polynomial. Again that will become easy. So when x is equal to 2, so we want to find the factors of this. So by substituting x is equal to 2, if it satisfies that, if it is satisfied, then it is that is said to be a one of the factor. So for that purpose, by substituting x is equal to 2 in this polynomial. 2 cubed plus 2 square minus 16 into 2 plus 20. That means 2 cubed means 8, 2 square means 4, 16 to the 32 plus 20. 8 plus 4, 12, 12 plus 20, 32 minus 32 is equal to 0. So that's why, therefore, here x minus 2 is a factor of this polynomial. So remaining two polynomials factors we want to find. So that's why x cubed plus x square minus 16x plus 20 I am taking. Here x cubed right as it is plus x square I am taking as minus 2x plus 3x square. Minus 2x square plus 3x square becomes x square. Again minus 16x I am split it as like this, minus 6x minus 10x. Again plus 20 I am writing as it is. Next, from first two terms which is common, x square is common, x square into x cube minus 2 will come. Again in these two terms which is common plus 3x common, again x minus 2 will come. Again in these two minus 10 common, x minus 2 will come. So totally in this equation what is common? X minus 2 is common. So by taking x minus 2 as common, here x square plus 3x minus 10 as there. So that's why again x square plus 3x minus 10. We for this also we want to find the factors. So here x square coefficient 1 constant minus 10. 1 into minus 10 is equal to minus 10. By multiplying minus 10 we want either adding or subtracting, we want to 3. So that's why like that factors we want to choose. 5 to the 10 plus 5 plus 2 is equal to 7, 5 minus 2 is equal to 3. So that's why 5 minus 2, 5 into minus 2 is equal to minus 10. So that's why x square right as it is plus 3x is nothing but plus 5x minus 2x minus 10. Again x square in these two terms x as common into x plus 5. Again in these two minus 2 common, x plus 5. Here x plus 5 is common. X plus 5 is common, remaining here x is there, here minus 2. So that's why for this x plus 5 and x minus 2 are factors totally. So that's why for that polynomial x minus 2 whole square into x plus 5 are the factors. As f is continuous at x is equal to 2, we know that continuous means limit x tends to 2, f of x is equal to f of 2, continuous definition. So that's why k is equal to, what do you want? F of 2 we want. So limit as x tends to 2, f of x is equal to, limit as x tends to 2, f of x value x cube plus x square minus 6x plus 20 by x minus 2 whole square. So we all know that x cube plus x square minus 6x plus 20 value x plus 5 into x minus 2 whole square. By already x minus 2 whole square is there. Here x minus 2 whole square, x minus 2 whole square is get cancelled. So limit as x tends to 2, x plus 5 is equal to, x is approaches to 2. So that's why 2 plus 5 is equal to 7. So that's why k is equal to 7 is the answer. So this is the one of the beautiful question. If it is clear, I will move on to the next question. That is CET, second question. CET 2002 question they are asking. CET 2002 they are asking this beautiful question. Find the value of k so that the function f of x is equal to sine pi x by 5x if x is not equal to 0, f of x is equal to k if x is equal to 0. This function is continuous at x is equal to 0. Then when this function is continuous at x is equal to 0, we want to find this k value. So we know that since f is a continuous function at x is equal to 0, then k is equal to f of 0. F of 0 is equal to what? F of a is equal to limit as x tends to a f of x, since f is continuous. So that's why f of 0 means limit as x tends to 0 f of x. Already f of x you know that sine pi x by 5x. So limit as x tends to 0, this one I am splitting by multiplying and dividing by pi into pi divided by pi. So this 5 I am writing here. We all know that limit as theta tends to 0 sine theta by theta is equal to 1. For that purpose, this one limit as x tends to 0 means pi x tends to 0 also, pi x also tends to 0. Sin pi x by pi x also 1. Okay, limit pi x tends to 0, sin pi x by pi x is equal to 1. So that's why 1 into pi by 5 as this formula. Okay, this value, k value must pi by 5. So this is a beautiful question. If it is clear, I will move on to the next question. This is also one of the beautiful question. CET 2017 question I am choosing. F of x is equal to 1 minus cos x by x square if x is not equals to 1, and f of x is equal to k if x is equal to 0 is continuous at x is equal to 0. If this function is continuous at x is equal to 0, we want to find k value. So for that purpose, k is equal to f of 0, that is equal to limit x tends to 0 f of x. We all know that f of x value 1 minus cos x by 1 minus x square. That is by approaching x is approaches to 0 means 1 minus cos 0 by 0 square. Cos 0 value 1, 1 minus 1 0, so that's why 0 by 0 form will come. So by avoiding this 0 by 0 by form, we must follow the L'Hospital rule. So that is limit as x tends to 0 by differentiating this numerator value, differentiation of 1 0 minus will as it is come, differentiation of cos x minus sin x by differentiation of x square 2x. So minus into minus plus, limit as x tends to 0 sin x by x 1 by 2. I am separately writing. Limit as x tends to 0 sin x by x value 1, 1 into pi by 2, 1 by 2 is equal to 1 by 2. K value is 1 by 2. Like this way, this CET all competitive level examinations. So this is one of the beautiful question. If it is clear, I will move on to the next topic, that is most beautiful and important topic, that is uniformly continuity. Uniform continuity. Uniform continuity means a function f is defined on an interval I is said to be uniformly continuous in the interval I. If for each epsilon greater than 0, there exists delta greater than 0 such that mod f of x2 minus f of x1 which is less than epsilon when mod x2 minus x1 which is less than delta for all x1 comma x2 belongs to I. So this is the uniform continuity definition. Here this delta belongs to the depends upon epsilon. So based on that there is two key points. First point, in the case of continuity of a function, at a point C, the choice of delta greater than 0 depends on epsilon greater than 0 and the point C. So in the choice of delta greater than 0 depends upon epsilon greater than 0 and the point C. So but in the case of uniform continuity of a function in an interval, the choice of delta greater than 0 only depends upon epsilon greater than 0, not on pair of points on the given interval. Okay, in the case of only uniform continuity, that delta greater than 0 depends only epsilon greater than 0, not depends upon that a given interval points, the pair of points. And if it is clear, I will move on to the next point, that is local property. Continuity at a point A belongs to C means continuity at a interval means A belongs to C. That is a local property. If it is clear, I will move on to the next topic, that is global property. Uniform continuity of a function is defined in an interval. That uniform continuity is defined only on an interval. This property is known as the global property. If it is clear, I will move on to the main key points, main key theorems on uniform continuity. This is important, very important points. Theorems. First theorem: every uniformly continuous function on interval is continuous on that interval, but converse is not true. Every uniformly continuous function is continuous on that same interval, but converse is not true. only if every uniformly continuous function is continuous on the given interval, but converse is not true. This is the first important theorem. Next, second important theorem is if f is a continuous on closed and bounded interval a comma b, then it is also uniformly continuous on the closed interval a comma b. F is continuous and closed bounded interval a comma b, then the function uniformly continuous on that closed interval a comma b. This is very important second theorem. Next, third theorem, if f is uniformly continuous on bounded interval I, then f is also bounded interval I. This is third theorem. Next, fourth theorem, if f is uniformly continuous in interval I, then the sequence xn is the Cauchy sequence of elements in I, then sequence of fn, f of xn is also a Cauchy sequence. If sequence is a Cauchy sequence, then sequence of f of xn is also Cauchy sequence. This is fourth theorem. Next important theorem, fifth theorem. The product of two uniformly continuous functions may not be uniformly continuous. The product of two continuous functions may not be uniformly continuous functions. Very important. Next, sixth theorem. If f and g are uniformly continuous on interval I, then its subtraction f minus g is also uniformly continuous on that interval I. Okay, if f and g are uniformly continuous on the interval I, then its subtraction f minus g also uniformly continuous on that interval I. This is sixth theorem. Seventh theorem. If f is uniformly continuous on interval I and k belongs to R, then k into f is also uniformly continuous on I. If you know these seven theorems, will make easily you will do the uniform continuous problems easily. So, if it is clear, I will move on to the next definition, that is Lipschitz function. Lipschitz function. Let S is subset or equals to R, and let f is from S to R be defined a function if there exists a constant c greater than 0 such that mod f of x minus f of x naught, which is less than c into mod x minus x naught for all x comma x naught belongs to S. Okay, this is a mathematical definition of Lipschitz function. So then f is said to be Lipschitz function. When you say that the function is a Lipschitz function, means if c is a constant c greater than 0 such that mod f of x minus f of x naught less than or equals to c into mod x minus x naught, this function value less than or equals to c into mod x minus x naught, then you say that f is said to be Lipschitz function. Next one, if f is defined from I to R, I tends to R is a Lipschitz function, then the function is uniformly continuous on I. The function is uniformly continuous on I. Now, if it is clear, I will move on to the problem based on this definition. This definition, first of all, we will see based on this definition problems. Again, shortcut method also I will introduce. This is for most important for net exam. Next, set exam. This type of questions most important for net and set exams. CSIR net and set exams. Show that the function f is defined f of x is equal to 1 by x, comma x belongs to interval 1 comma infinity is uniformly continuous on this interval. So first of all, you see the based on this definition, let c belongs to the given interval such that c is greater than or equals to 1 for all x greater than or equals to 1. So that implies this c into x also greater than or equals to 1. Okay, we will use this condition. So next we want to check definition. What do we want to check? This one we want to check what will happen to this value. So if it is less than or equals to x minus c, then we say that f is uniformly continuous. So for that purpose, mod f of x means 1 by x, f of c means 1 by c. So by simplifying this, mod c minus x by x minus c, since mod cx is greater than or equals to 1, so that's why this value is less than or equals to mod x minus c, less than or equals to mod x minus c. So that's why what we'll get, mod f of x minus f of c less than or equals to mod x minus c. So this is in the form of c into mod x minus c. So that's why according to definition, this one, let us choose epsilon greater than 0, then for all x is greater than or equals to 1, by satisfying this condition, for mod f of x minus f of c less than epsilon, which is less than mod f x minus c, which is x minus c, which is less than delta, by choosing delta is equal to epsilon. That means here mod f of x minus f of c, how much we got it? Less than or equals to mod x minus c, we got it. This value which is less than delta. If it delta is equal to epsilon, then we say that the given function is uniformly continuous. So by this way we will prove the uniform continuous on this given interval. This is the mathematical definition. According to mathematical definition, this is the f is uniformly continuous on this interval. So based on this mathematical definition, one more problem we want to see here. Problem 2. This is also very important for NET and SET exam. NET and SET exams also very important. So is the function f of x is equal to x by x plus 1 uniformly continuous for x belongs to this interval? We want to check it. For this purpose, let x comma y belongs to the let x comma y be the two arbitrary points in this interval. Then x greater than or equals to 0 and y greater than or equals to 0. By adding 1 on both sides, what will happen? X plus 1 greater than or equals to 1, and by adding 1 also for this, y plus 1 greater than or equals to 1. Then again, by producing these two terms, x plus 1 into y plus 1 will get which is greater than or equals to 1. Now we want to check this value, mod f of x minus f of y value. So if it is equals to mod x minus c, we say that this given function is uniformly continuous. So that's why for this purpose, according to definition, f of x is equal to x by x plus 1, f of y is equal to y by y plus 1. By simplifying this, x into y plus 1 minus y into x plus 1 by x plus 1 into y plus 1. So here y plus 1, which is y plus 1 value which is greater than or equals to 1, as well as x plus 1 also greater than or equals to 1. So that's why this value 1, x into 1 x, y into 1 1, y into 1 y value. So which is this value also, this mod value also 1 greater than or equals to 1. So that's why this total value less than or equals to x minus y, which is equal to delta, since this value. So mod f of x minus f of y less than epsilon, epsilon greater than 0 be given. We take delta is equal to epsilon. Here delta is equal to epsilon taking. So that's why mod f of x minus f of y less than epsilon means we say that f is uniformly continuous on given interval I. So like this way, by mathematical definition, f is uniformly continuous. So if it is clear, I will move on to the shortcut method. How to check the uniform continuous in the closed interval a comma b. How to check shortcut method I want to introduce here. This method is very important while you are attempting NET and SET examination. Why? Because within less than 5 minutes only we want to attempt the question. For that purpose, we are introducing this shortcut method. So step 1, f of x is continuous in closed interval a comma b. Second step, limit as x tends to a f of x and limit as x tends to b f of x both exist and finite. Then if satisfied these two steps, then we say that f is uniformly continuous. So based on this one small theorem, f is uniformly continuous on open interval a comma b if and only if limit as x tends to a plus f of x that means RHL, and limit as extends to a minus f of x, that means LHL value both exist and finitely, if f is uniformly continuous on closed interval, open interval a comma b. So based on this shortcut method, we'll discuss some problems. These are the I am choosing in CSR net problems. I am choosing here CSR net problems. Here 40C CSR net December 2016 40C question. Decide which of the following functions are uniformly continuous on open interval a comma b. Functions are like this: f of x is equal to e power x, and f of x is equal to x, and f of x is equal to tan of phi x by 2, and f of x is equal to sine of x. Now we want to check which functions are uniformly continuous. We want to check it by shortcut method. So here, see here, option A, f of x is equal to e power x. We know that e power x exponential function is always continuous. So according to this, by shortcut method, first step is satisfied under this interval. So that's why this exponential function is continuous. Now we want to check this second step, limit as extends to a and limit as extends to b. We want to check it. Here a is equal to 0. Here a is equal to 0 and b is equal to 1. Limit as extends to a, f of x is equal to limit as extends to 0, e power x, e power x. E power x means how much? 0. E power 0 means 1, exist and finite. Again, limit as extends to b, f of x, b is equal to 1. Limit as extends to 1, e power x is equal to 1. E power 1 is equal to e is equal to exist and finite value. So both are finite and exist and finite. So that's why the given function is uniformly continuous on this interval. So that's why option A is the correct option. Option A is the correct answer. This way we will check the given function is uniformly continuous. Like this way, second option. F of x is equal to x. This is a linear function, so that's why this is also a continuous function. First step is satisfied automatically. Second step, we want to check under this interval, that is limit as extends to f of x means limit as extends to 0, x means x is approaches to 0 means 0, exists and finite. Next, limit as extends to b, f of x means limit as extends to 1, x is approaches to 1 means this value is 1, this value is 1. So that's why this 1 is also exist and finite. Here also both limit extends to a and extends to b, both are exist and finite. So that's why f of x is uniformly continuous on this interval. So that's why option B also correct option. Next we want to check this function. F of x is equal to tan of pi x by 2. We all know that the trigonometric function is continuous. So that's why first step is satisfied. We want to check the second step as limit as extends to a, f of x, and limit as extends to b, f of x. We want to check if both satisfied exist and finite, then we say that f is a uniformly continuous. For that, limit as extends to a means how much? 0, f of x. So f of x is equal to tan pi x by 2. As limit as extends to 0, so that's why pi into 0 by 2. This value 0, tan 0 value 0. This value is exist and finite. So next, limit as extends to 1, f of x is equal to limit as extends to 1, pi of x value, f of x value, tan of pi x by 2. As extends to 1 means tan pi by 2 will come. Tan pi by 2 value not defined. So that's why this is not exist and not finite, not exist. So that's why given function is not uniformly continuous on this interval. So that's why option C is not correct. Option C is false. Next, option D, f of x is sin x. We all know that trigonometric function is continuous on this interval. So that's why we want to check the second step. Limit as extends to 0, f of x is equal to limit as extends to 0, sin x, or sin limit as extends to 0, sin 0 is equal to 0, and exist and finite. Next, limit as extends to 1, f of x means limit extends to 1, sin sin x. Sin 1 value, we know that 0.8414 value. This value also exists and finite. Here both exist and finite. So that's why given function is uniformly continuous on 0 comma given interval 0 comma 1. So that's why this D also correct option. So that's why here options A, B and D are correct. C is the false one. So in this question, beautiful question, CSR net to December 2016 part C question, option A, B and D are correct. C is the wrong answer. C is the wrong answer. If it is clear, I will move on to the next question. So next question also I choose the part C CSR net question. Part C CSR net question. See here, this is June 13 question. Very beautiful question. Which of the following function f is uniformly continuous in given interval 0 comma 1? Here functions are like this. F of x is equal to 1 by x. F of x is equal to x into sin 1 by x. Here f of x is equal to simply sin 1 by x. Here f of x is equal to sin x by x value. We want to check it each and every case. First one, f of x is equal to 1 by x. We all know that this is a rational function. Rational function is always continuous. 1 by x is a continuous function. So that's why we want to check next further step on this interval. Further step we want to check it. So that is limit as x tends to 0 f of x is equal to limit as x tends to 0 1 by x is equal to 1 by 0 not defined. Not defined means this function is not uniform continuous. So for our mathematical step, we want to check the second step also. Limit as x tends to 1 f of x is equal to limit as x tends to 1 by x. 1 by x means 1 by 1 is equal to 1. This is exist. Even though it is exist, first one is not exist. So that's why given function is not uniform continuous on this given interval. So that's why first option is a wrong option. Second option, f of x is equal to x into sin 1 by x. This is also one continuous function. F of x is a continuous function on this interval. So that's why we want to check further step. So limit as x tends to 0 f of x is equal to limit as x tends to 0 x into sin 1 by x is equal to, as x tends to x is approaches to 0. So that's why 0 into this value 0 is exist and finite. Next, limit as x tends to 1 f of x is equal to limit as x tends to 1 f of x means x into sin 1 by x, that is 1 into sin 1. 1 into sin 1 value also finite. So sin 1 value 0.8414. So that's why this is a finite. So finite and exists. So that's why given function is uniformly continuous on given interval 0 comma 1. So that's why option B is the correct answer. Next one we want to check the C option. So that is sin 1 by x. Sin 1 by x we all know that trigonometric function is a continuous function. So further step we want to check limit as x tends to 0 f of x is equal to limit as x tends to 0 sin 1 by x, that is equal to limit as 1 by 0 not defined. So that's why 1 is not defined. So that's why we will say that f is not uniformly continuous on given interval. So that's why option C is false. Next, option D. Option D is sin x by x. We all know that sin x by x is continuous function. So that's why we want to check further step. Limit as x tends to 0 f of x is equal to limit as x tends to 0 sin x by x. This value we know that this value is equal to 1 exist and finite. So that's why limit next step limit x tends to 1 f of x is equal to limit as x tends to 1 sin x by x. Sin x by x means sin 1 by 1. Sin 1 by 1 is finite. This value is equal to 0.8414. So this is finite and exists. So that's why given function is uniformly continuous on the interval 0 comma 1. So that's why this option is also correct option. Totally the B and C are the correct options of these questions. B and D are the correct options and A and C are the wrong options of this question. A and C are the wrong options. So with this question, this continuity topic is completed. Hello my dear friends. If you not subscribe my YouTube channel, please subscribe my YouTube channel, like this video and share to your friends. Thank you. Thank you very much. Thank you one and all. If you not subscribe my YouTube channel, please subscribe my YouTube channel as Tirunagaram Manohar. If you not subscribe my YouTube channel, please subscribe my YouTube channel as Tirunagaram Manohar. Thank you very much. Thank you one and all.